What we want to do in this segment is objective 3.7, which is RIP, configure, verify, troubleshoot RIP v2 for IPv4. And that excludes authentication, filtering, manual summarization, redistribution. So it's the basic configuration of RIP v2, which we'll do here in a minute, but need to talk about RIP for a couple of minutes before we get there. What is RIP? Routing Internet Protocol. It is a distance vector protocol, uses hop count as a metric for path selection. And we talked about this a little bit. If I have these 2 points and I have this way, it's got a gig here and a gig here, and this is a 256K. It's going to take the lowest hop count, which is going to be straight across the 256K. So it does have some limitations in the hop count, setting up the network. It only is acceptable for use in a small network. 15 is the maximum hop counts, 0 to 15, which is going to give us 16. So if you see a hop count of 16, that's infinity. So, and infinity means that it is no good. When we go down here, where it's a route poisoning, when we do a route poisoning, a route goes down, we'll send a hop count of 16 in order to poison that route. 4 basic components: routing update process, the RIP process, the routing metrics, stability, and timers. There are a number of timers that we won't get into explicitly. Biggest ones, well, we will here, a hold down timer. Once a route has been declared as down, we wait a certain amount of time before we're going to take updates on that route. Say, yeah, it's back up from other routers. If it comes from the device that it went down on, then we'll go ahead and accept it, because we figure directly connected knows whether it's up or down. Exchange for information within an autonomous system of a small network. An autonomous system is one that's under administrative control, a single administrative control. So we would own our local network. We would have access to all the resources and be able to configure them. A limit on the number of hops allowed, source and destination paths, 15, and again 16 is equal to infinity, which means that we're not going to get there anymore. Split horizon says that it implements split horizon, says if I get an update in on an interface, I can't send it out on that interface. So if I have, and this can cause an issue here with split horizon, if these things, and they're not, but if we were using a sub interfaces here in a frame relay and they were all connected here, then these routes could never get here, because as they came in on this interface, they couldn't go out on this interface. But this is to prevent sending bad information. Our route goes down over here, sends the route poison to this guy, and then he's looking for a path to 10.12.15.1. This guy has not gotten the modification yet, so he sends him the path to the down network through an interface that information came from, because the way to get to this network would obviously come from this interface, so you're not allowed to send it back. Prevent some information from doing that. Hold down mechanisms prevent incorrect routing information from being propagated. Hold down means we're going to wait a certain amount of time before we're going to accept any updates to the networks that have been declared as down. The difference is RIP v1 and v2. We have 2 versions of RIP. RIP v1 has been around for a long time. Very simple protocol. V1 used different techniques to handle a set of features. The message format, RIP v1 consists of the command version, family network address, and distance fields. In addition to these, RIP v2 has 3 new fields: route tag, subnet mask, next hop address. RIP v1 is class full, which means that we can't subnet it. RIP v2 is class less, which means that we can subnet it. And that's what the subnet mask is all about, how much of the network is network. RIP v1 uses class full addressing, the ones that we talked about, the 1 to 127, and then 128, 192, class B, class C, and then 01 to 127, with 127 being the loopback address, the reserved one for the class is. Multicasting and encapsulation. RIP v1 broadcasts messages to every neighbor so that all the routers of the network receives a packet. So it uses broadcast, and it broadcasts every 30 seconds. RIP v2 uses multicasting to send messages only to RIP v2 routers. Multicasting, if you'll recall, goes to a set of devices. So what the multicasting will do, if RIP v2 is being run on that router, then it's going to get the updates. So and that's the way that they subscribe to the multicast group, is by having the protocol run on the device. RIP v2 for IPv4 supports authentication, which is not part of this exam because you don't have to configure that. Authentication, key management, route summarization, CIDR, as well as VLSM. CIDR and VLSMs we've talked about. Route summarization is what we would call supernetting. And an example of that would be if we had, let's say 172.16.1.0 and then 172.16.2.0. We could change the subnet mask so that it would incorporate all these. I guess an easier one is we had a 10.60.something.something, 10.60 or 16 doesn't really matter, and we mask it at 255.255.255.0. If we wanted to summarize the routes, everything starts with a 10.60, then we could do that 10.60.0.0 with a 255.255.0.0. So anything that starts with 10.60 is summarized into a single address. Handy way to manipulate the subnet masks there. So RIP v2 offers supports automatic summarization by default. If you don't want it to summarize, you have to tell it not to summarize. The software summarizes subprefixes of a classful boundary when a classful network boundaries are crossed. So it summarizes to the classful boundaries, and that's what most of the ones that summarize are typically going to do. Process for building and maintaining a route table, and I think we've talked about this a little bit before. 3 processes. The various routing processes that actually run on the network are EIGRP, BGP, ISIS, and OSPF. What we're concerned with in CCNA is OSPF and EIGRP, EIGRP being the Cisco proprietary one. The routing table accepts the information from the routing process and replies to the request for information from the forwarding process. These guys, we talked about, this one's going to be a multicast, and this one only updates if there are changes. So eliminate the number of things that are sent, and then RIP, as you recall, is a broadcast. The forwarding process requests the information from the routing table to use the information to make a packet forwarding decision, and all of that down here is a RIP. Here we have network. It says, hey B, I know about network 1, 2, 3, and 4. So we have 3, 1, 2, 3, and 4 in the route table, and it sends out information to router B here. It says, yes, I've added network 4 and I sent an update to A. So when we get this thing, 30 seconds broadcast, because this is a broadcast domain in here. Waits 30 seconds here. So it's going to be a minute before this guy theoretically gets the information about E1. If it goes down, got to wait for that to happen. As a new route comes in, a new network comes in, you've got to wait for the network to synchronize to, so that everything is in convergence, and convergence is the term that we use when everything has the same information. And they're going to have it for a few minutes because it's going to change again, probably, hopefully not so much in routers. So the little overview here, RIP was a distance vector protocol. It uses hop counts, and we had two versions of V1, which was the classful, and the V2, which is classless. So now let me drag over here and let's do the configuration that I promised you, because we have some networks here, 192, 168, 3 network here, the 2 network here, the 1 network here, and the 4 network over here. 172.16.2 network connects these two routers together, and the 172.16.1 connects these together. So in order to configure RIP, we'll go in here, and what I like to do to know which ones to advertise, because we've said previously, let's show IP route. Get type if I can find the letters. I guess not. I really can't, can I? Show IP route. We have a bunch of things that are connected. To make this one easier, we should be able to just show the connected one. So we have 172.16. The reason I like to do this is now we're going to the configuration, config T, and then we'll do router RIP. Now we have to tell the world which networks we know about. So we'll type in network, and then the first one is 172 says 168. 168 should be 16. 168.1.1. I'll put that one in. It'll take it. I'm going to pause this and fix that, because this address should be 172.16, which it is on the other end. Let me fix these and I'll be right back. Okay, I think I got that fixed. Let's do an exit. Exit goes up one layer, and we can use a do show IP route. So now we have the 172.16. What I need to do is to go back and undo the one that I did, which was 172.116. So we'll go to router RIP, and then we'll do no network 172.168.1.0, and then we'll do network 172.16.1.0, and we'll do the question mark. The only thing that's available is a carriage return. And then we'll do network 172. No, it's not. It's 192.3.0. And I need to specify the version here. So we're going to say version 2 in the router command. If I show IP route, we still don't have anything except our connected. The L's here again local. You notice they are the addresses. So let's go up to this guy and see if we can actually get some information going here. I checked them all. That's what that's about. And here we'll go config T and router RIP. Let's do version 2. And I can use the do command to execute a command outside of where it's should be done, because the show IP route connected is not a legal command here. So you can use do in order to execute other commands. Do show IP route, and we'll do connected. So we have the 172.16, 172.16.1, 172.16.2, 192. So what we're going to do is go ahead and do those. And I forgot if I did. I didn't do the version 2. Yeah. So we're going to do network 172.16. So that's how I get the 8. 16.1.0 and network 172.16.2.0. I like to use the up arrow key. It recalls the commands, and then I make fewer typos. 192.168. 2 and .1 and .1. So show IP route. And not doing anything yet. So now we get to do the troubleshooting part of it. So show run router RIP version 2 172.16.0. That won't work, will it? 172.16.1 and 172.16.1.2. So config T router RIP 16.1.0. You probably saw that and said, oh, you really messed that up, didn't you? Show IP route, and we still don't have any. So let's show IP protocols, and it says that serial, we got these, and 172.16 routing for networks 172.16 192 168.1 172.160. It says that we are doing the right things there, doesn't it? And then this one, show IP protocols 172.6. Okay, see, here we go, 172.168. Okay, so config T router RIP network 172.16.0 show IP route, and now we have RIP routes. We have the R's here we're talking. So a little bit of how you might go about the troubleshooting. Typos are a big one of that. We could have done a debug IP RIP. Routing is on, a debug RIP routing protocol is on, and we'll wait a few minutes. There we go. This is the update. To get out of this, turn off debugging, but the ones that we configured 0030 received a v2 update from 172.16.1.1, which is the other router for these networks. So that is the configuration and some troubleshooting of RIP for IPv4 without all of the authentication or those sorts of things, filtering, summarization, or redistribution. So a basic RIP v2 is the protocol. Do we have the right protocol? Do we have the right version? Do we type in the right network addresses? Do we have the right IP addresses on the interfaces? All different things that you saw. I messed up. So a little bit of troubleshooting. I usually get to do a lot of troubleshooting when I do these because I type too fast and make mistakes. So that should take care of Objective 3.7 RIP v2.